Hi guys, so today we're going to transition from exponents into logarithms. So logarithms are actually very related to exponents. In fact, they're inverses of each other. And really the easiest way to work with a log is to rewrite it as an exponent. Okay, I always like to call logs just exponents in disguise. So the reason we need logs is, let's say we're trying to find an exponent. All right, let's look at this first one. 2 to the x equals 4. Well, I can figure out pretty easily that x is 2. All right, 2 to the x equals 8. I can figure out pretty easily that x is 3, because 2 to the third power, 2 times 2 times 2 is 8. The problem is if I have something like 2 to the x equals 6. Well, I have no way of knowing exactly what that is without just continually plugging in lots and lots and lots of numbers with very specific decimals, and that would take forever. So this is where logs come in. Now, I do know it's going to be between 2 and 3, so I can estimate it, but again, logs are going to give us that exact answer. So what a log is the inverse of an exponent. It's basically a rewritten form of an exponent. So let's say I have this log like this. So the first thing I'm going to do is I'm going to tell you guys what those parts are. All right. So every log has a base. Okay, that's the little number that's written next to it. Now that base sometimes isn't written. Sometimes that base is implied, and we'll get into those special cases here later. But every log has a base. Then the thing that follows is called the argument. Okay, this is something you may have heard back when you did trig. So like if you had the sine of 13 over 15, that 13 over 15 was the argument of the sine function. It's what you're actually taking the sine of. And actually you wouldn't have taken the sine of 13 over 15, you would have done sine inverse, but you get the point. If I'm doing the sine of 30 degrees, okay, 30 degrees would be the argument. It's what you're taking sine of. Really, the point here is you can't just have sine by itself. It's always the sine of something. It's always the cosine of something. Well, same thing with logs. You're never going to have just log. That's not a thing. But you'll always have the log of something, whatever the base is of something. And that something that follows is called the argument. You're going to hear me use that word a lot throughout this unit. All right, so every log has a base, and every log has an argument. Now there's some specifics about those things, and we'll get into those after we look at a couple examples. All right, now every log is an exponent rewritten. All right, so if I have log base b of y equal to x, the equivalent exponent would be b to the x equals y. Now what's nice about this, remember how we said this was the base of the log? Well, back when we talked about exponents, we talked about the base of the exponent. Those are going to be the same number. So the base of the log is the base of the exponent. And really, I think the easiest way I've always rewritten these is I start at the base and I go in a circle. So b to the x is equal to y. All right, so let's look at an example and let's just rewrite it. So log base 6 of 216. That's how I would read that. Log base 6 of 216 equals 3. So 6 to the third is equal to 216. All right, on the next one, the base is 7, so the base of the exponent is 7. 7 to the 0 is equal to 1. Start at the base, go around. You also could look at it, write your base, flip your other two numbers. Okay, so start at the base and flip your numbers, either way. Okay, 21 is the base. 21 to the first equals 21. Start at the base. 1/5 to the negative 1 equals 5. So that's how we rewrite a log into an exponent. All right, so now that we know that, I want to talk about a couple things about logs. So if you notice, there's a lot of little special qualifiers here. And we're going to talk about why these things are true. So first of all, y has to be greater than 0. That means the argument cannot be a negative number. Now that's true for a couple of reasons. So first of all, this can't be a negative number because let's say I try to evaluate it. Let's say I have log base 2 of some negative number. Let's say negative 2 is equal to something. Well, if I were to rewrite that in exponential form, 2 to the something power is equal to negative 2. Well, that's not possible. I can't raise 2 to any exponent and get a negative number out of it. Even a negative exponent, it doesn't make the number negative. A negative exponent makes it a fraction. Okay, think back to your exponential parent function. Your exponential parent function had that asymptote because, again, we couldn't get those negative numbers if the base was positive. So it's not possible to have a negative argument for the log. The other reason it's not possible, again, these functions are inverses. Now we're going to come back to this later on and spend more time, but think about it. If I have the function y equals b to the x, well, if I were to find the inverse, x equals b to the y, I could rewrite this as a log. So if I rewrite this as a log, this would be log base b of x equals y. So this is the inverse of the exponential function. Okay, so log and exponential are inverses of each other. That's just kind of the math behind it. Well, if those are inverses, think about the graphs. Okay, remember how we talked about domain and range? The range of the exponential is the domain of the log. And we'll come back to log graphs later on and spend more time. This is just to kind of give you guys a little bit of an overview, a little bit more detail. So if it's log of x, okay, look at all the x's that are on this graph. All those x's are positive numbers, because again, it's the inverse of exponential. Okay, so all of that to say, the argument cannot be negative, and that's going to be really important when we get to solving, because that's a way we'll have extraneous solutions. All right, so let's talk about something else. It also says that b has to be greater than 0, and b can't equal 1. Well, this follows the same idea that we talked about with exponents. Okay, when I had exponential functions, I couldn't say 1 to the x was an exponential function, because 1 to the any power is just 1. It's just a horizontal line. All right, it also has to be positive, because remember, if we said we had a negative exponent base, all right, this had a problem for a few reasons. So if I had negative 3 to the x power, okay, well, if x was an odd number, then I would get a negative number. If x was an even number, I would get a positive number. So this graph would kind of bounce back and forth, and it wouldn't really be a very clear function. What's even worse than that is if, let's say, x was 1/2. I'd be taking the square root of a negative, and that's not possible either. So the base of an exponent can't be negative, the base of a log cannot be negative, because again, it's just not that function. All right, so that's a lot of detail about logs. Let's get into a little bit more of the practical stuff. If that whole part was a little bit confusing, again, we're going to come back to that stuff over and over again. The really important things to get for today is the rewriting, and then when we get to the evaluating here later on. All right, so we already worked on rewriting a log into exponential form. So now what we're going to do is we're going to rewrite an exponential expression into its log form. So let's take this first one. 9 to the second equals 81. Well, the base of the exponent is the base of the log. And then I swap the other two numbers, or I go in a circle. So it would be log base 9 of 81 equals 2. All right, look at the next one. Base of the exponent. The base of the exponent is the base of the log. So this would be log base 20. Then I flip the other two numbers. 0.05 equals -1. All right, then let's look at the next one. Again, log base of the exponent is the base of the log. So base 16, flip our other numbers, of 8 equals 3/4. And then the last one, base of the exponent, base of the log. So log base 15 of 1 over 225 is equal to -2. All right, so that's how we convert back and forth between these two forms. This is going to be really important, especially converting from log to exponential for what we do today. All right, but the most important thing really to get out of this is how to be able to rewrite them. All right, so now what we're going to do is we're going to evaluate some logs. So if we understand how to rewrite them, evaluating them is basically finding the missing exponent. So log base 4 of 64, all right? We want to evaluate it. It's not an equation, but let's just say this equals x. If this were to equal x and I wrote it in exponential form, I would do 4 to the x equals 64. So all I need to do is find the exponent. So 4 to the what power is 64? Well, 4 to the third power is 64. That means that log base 4 of 64 is 3. Now, I'm not going to say x equals 3 because it's not really an equation, but that just helps me with the setup to be able to figure out what this is. All right, looking at the next one. Again, 8 to the something power equals 1 over 64. Now this is really when it's really going to help you guys out to be familiar with your exponent rules, okay? So remember the two exponents that sometimes get missed, negative exponents and fraction exponents. Negative exponents move those bases to the opposite side of a fraction. So for example, 4 to the negative second would be 1 over 4 to the second. Fraction exponents were roots, so 4 to the 1/2 was the square root of 4. So those are going to be really helpful for evaluating these logs. All right, so 8 to the something power is 1 over 64. I don't know why I wrote 16. So 8 squared is 64, but because it's at the bottom of the fraction, it's going to be -2. All right, look at my next one. 81 to the something is equal to 9. Well, I know the square root of 81 is 9. Square root as an exponent is 1/2. All right, next one. 1/3 to the something equals 27. Well, to go from a fraction to a whole number, that needs to be a negative exponent. It works both ways. So a negative exponent would flip that. So this would be 1/3 to the negative third power. The negative would flip it. 3 to the third is 27. All right, so the next two, you may be able to do without showing work, depends on how good you are with your exponent properties, but I'm going to show you guys kind of two different ways to do this. Okay, so the setup here, this would be 27 to the something power equals 81. So the problem here, it's not really a really clear, easy answer. Now, if you're really good with your exponent properties, you may notice if I take a certain root of 27 and raise that number to a power, I'm going to get 81. And if you can see that, that's great. That's going to save you a lot of time. If not, this will help you guys when we get to solving. What I'm going to do is I'm going to rewrite these two numbers in terms of the same base. Well, 27 and 81 can both be written with a base of 3. 27 is the same thing as 3 to the third. 81 is the same thing as 3 to the fourth. Well, 3 to the third still has that x on it. So these two things are just rewritten. Well, now since the bases are the same, the only way that these are going to be equivalent is if those exponents are the same. So then what I would do is just take 3x equal to 4. So x is going to equal 4/3. All right, and then let's look at our last one. 5 to the something power is equal to the square root of 125. So this is another one that's pretty hard to see. So again, I'm going to start by rewriting it. So the square root of 125 is 125 to the 1/2 power. 125 is the same thing as 5 to the third power. So the square root of 125 is 5 to the 3/2 power. Well, once it's rewritten, they have the same base, so x is going to equal 3 over 2. All right, another way that you could work this one out, if it's easier for you, we could square both sides. Now, what we don't want to do is just square one side. That changes it entirely. We need to be careful about that. But if we square both sides, I can make this 5 to the 2x equals 125, and then I can work this out the same way as the previous question. 5 to the 2x equals 5 to the third, 2x equals 3, and I still get the same answer. So whichever one makes more sense to you. Just be careful, again, if you're squaring something, you have to square both sides. If you're just rewriting it, notice on this, all we're doing is writing an equivalent form. All of those mean the exact same thing. We're just rewriting it to make it easier to see our answer. So those last two are a little bit harder. And they really help if you guys are more familiar with your exponent properties. So if you need to go back and review those, you can go back and find that old video if you need to. But it's really important for you to be familiar with your exponent properties to make these easier. Okay, so now what we're going to talk about are some special bases. And what that means basically is the base is not written, okay? But the base is implied by the way the log is written. So if you notice on your calculator, you'll probably notice there's a log button. And it just says log. It doesn't allow you to put a base in. Well, a log without any base is referred to as the common log. And that actually has a base of 10. So you'll never see log base 10 of something. Okay, you'll always see just regular log. So if you see log and there's no base, that base is 10. So to rewrite this in exponential form, it would be 10 to the second equals 100. All right, so again, if the base is 10, I wouldn't write that as log base 10 of 100,000. All right, what I would write instead is just log of 100,000. So if there's no base, the base is 10. Well, now there's a special one, okay? This is called the natural log. So it's ln. I know it's backwards, but I think it's French, something like that. ln is the natural log, and that is a log with a base of e. So again, you'll never see log e, okay? Instead of log e, you'll write ln. So ln stands for natural log, and this one will be really important, especially in the future for calculus. So if I see ln of something, the base is e. So I would rewrite this as e to the fifth equals 148.4. Okay, if I were to go the other way, e to the something power. Well, this would be log base e of 1096.6. But again, we don't write log base e. We would write ln. And that's going to equal 7. All right, so same thing we were doing with evaluating, just looking at those special bases. So log of 1,000. Okay, the base isn't written, but that base is 10. 10 to the something power equals 1,000. Well, there's 3 zeros, so that's 3. All right, looking at the next one. 10 to the something power is 1 over 100. To move it to the bottom of the fraction, it's a negative exponent, so this is negative 2. All right, log base 10 cube root of 100. So this is another one of those kind of tricky ones. So 10 to the something power. So I'm going to rewrite this as 100 to the 1/3, because that's what cube root is. Then I'm going to rewrite 100 as 10 squared. So now x is 2/3. All right, and then let's look at some natural logs. Okay, so the base here is e. So e to the something power equals e. Well, in order to make it itself, it has to be 1. And what I really like about this one, it kind of looks like the word 1. Okay, you just turn that into a little 0 there, and you got the word 1. All right, looking at the next one. E to the something power equals 1. Well, anything to the 0 power is 1. So in this case, it's 0. Now these two, actually, it doesn't matter what log base this is. If the base of the log is the same as the argument, it's going to equal 1. And that's just a property of logs. Okay, if the base and the argument are the same, your answer is 1. Same thing, no matter what the base is, if the argument is 1, that log is going to equal 0. It doesn't matter what your base is. All right, then the last one, ln of e to the 7th. So again, base of e to the something power equals e to the 7th. Well, that has to be 7. All right. So the last thing we're going to look at is what we do when we can't actually evaluate it and figure out what that exponent is. So we can actually use the calculator to find these specific ones. So let's start with this first one, log base 3 of 7. Okay, I don't know, 3 to the something power is 7. I don't know what that is. So this is the case where in order to evaluate this, I'm going to have to use a calculator. So if you have a Casio, go ahead and get it. Go ahead and look at the run matrix screen. So then from this screen, what we're going to do is we're going to start by going to math. And then you'll see log AB, which is F2. So that is going to allow you to enter a log base that's something other than 10 or E. So I want log base 3 of 7. And that gives me 1.771. So 3 to the 1.77124, etc. power is going to equal 7. Okay, again, just to double check, 3 raised to that answer is 7. Now, what you're probably thinking is, well, if I can just evaluate these with the calculator, why did I just go through all of that work that we just did? Now, what you guys need to be aware of, when we're working at home, I know you're going to have a calculator with you all the time. But the questions that we just did, when you get to pre-cal and you get to calculus, you're going to need to be able to evaluate those without a calculator. So it's really important for you guys, if it doesn't say to use a calculator, you need to try it without one. I know you can just plug these into a calculator and get an answer, but that's not what we're trying to work on right now. And it's really important for you guys to understand how to do these without it so that it'll be easier on you when you get to pre-cal and calculus. Okay, so let's do a couple more. So we're going to rewrite, we'll do ln of 4. Okay, so ln of 4, if you don't know where that is, ln is where that E button was we used before. So there's ln. Also, if you need log base 10, that's right next to it. If you ever forget, what's nice too, 10 to the x is above log because the base is 10. E to the x is above ln because the base is e. Okay, so we're going to use ln. So we are doing the natural log of 4. And there's my answer because e raised to that power is 4. All right, next one, natural log of 3e. Okay, so I would do ln. I'm going to open up some parentheses, 3, and then I can do shift ln. And I just want one e, so I'm just going to do e to the first. It automatically gives me an exponent. And that's the ln of 3e. All right, now the last two, in order to value those with the calculator, we have to be able to rewrite them into log form. So this first one might look familiar. It was the very first one on the notes. Well, in order to evaluate this, let's rewrite it as a log. Log base 2, because base is the base, switch the others, of 6 equals x. So if I want to know what x is, I'm going to evaluate log base 2 of 6 on my calculator. So this is going to be log AB, base 2 of 6. So 2 to the 2.585 power would equal 6. All right, and the last one, again, we'll go ahead and rewrite this. This would be log base 10, so I can just write regular log of 14 is equal to x. So I would just plug in log of 14. So log 14, and I get my answer. All right, if you don't have a Casio, I know some of you guys are using a TI. If you have a TI, you can still do a log base. It's a little bit different, but what you'll do if you have a TI is you'll do the green alpha button and then window, which is at the top near y equals. Then you're going to see kind of this menu pop up, and then from there, you can do log base. All right, and then you're able to enter those different bases. All right, so that's it for today. So you already did the ed puzzle. And hopefully we're doing your notes at the same time. The practice problem is kind of like it's been the last couple of weeks. Those are going to be optional. The key is there if you want to check it. The practice grade for today is the quizzes, okay? Now this is one of the last times we'll do that. It's just because these are such short, kind of quick questions. It's really good to kind of just do a couple of them on that quizzes. But once we get to solving and showing more work and things, we'll get away from the quizzes. If you need help in those practice problems, you can email me, fill out that video request by 4 p.m. Tuesday, or we have the Zoom session from 2 to 3. And then once you are done with Thursday's material, you can do that week 5 assessment. Again, if you have any questions, feel free to reach out.